So in this video, we are going to talk about some more problems in situations where we would use greatest common factor or least common multiple. So as you go through this ed puzzle, I want you to go ahead and try to answer this on your own and put in your answer into the ed puzzle and then check your work with mine as we go through. So for problem 1, it says that Cameron practices the trumpet every 11th day and the flute every 3rd day. Cameron practiced both the trumpet and the flute today. So how many days until Cameron practices the trumpet and the flute again in the same day? So first of all, I want you to answer, is this going to be a greatest common factor problem or a least common multiple problem? If you answered least common multiple, you are correct. So let's go ahead and find the least common multiple between 11 and 3. So if every 11th day he practices the trumpet, that would be day 11, day 22, day 33, day 44, day 55, and so on. If he practices the flute every 3rd day, that would be every 3 days, every 6 days, every 9 days, every 12 days, every 15 days, every 18 days, every, 3 times 7, 21 days, every, 3 times 7, 3 times 8, 3 times 9, 3 times 10, and 3 times 11. So the least common multiple they have in common with each other would be 33. So Cameron will practice the trumpet and the flute again in the same day on the 33rd day. Now, if Irma is serving vegetables at a soup kitchen, she has 50 carrot sticks and 40 baby potatoes that she wants to divide evenly with no food left over. So what's the greatest number of plates Irma could prepare? Are we going to find the greatest common factor or are we going to find the least common multiple? If you said greatest common factor, you are correct, because what she is doing is she is taking the 50 carrot sticks and the 40 baby potatoes, and she's trying to make bowls of vegetable soup with them. So we want to find out how many of each she can put in each bowl. So let's use our prime factorization to help us out. We have 50 and we have 40. I'm going to break 50 into 5 and 10, 10 into 5 and 2. So my prime factorization of 50 would be 5 times 5 times 2. For 40, I would break it up into 10 and 4, 10 broken up into 5 and 2, and 4 broken up into 2 times 2. So my prime factorization of 40 would be 5 times 2 times 2 times 2. Now those are my prime factors of 50 and 40, but to find the greatest common factor, I need to find what they have in common. So they have a 5 in common and they have a 2 in common. So their prime factors in common would be 5 times 2, which is equal to 10. So Irma would be able to put 10 bowls of soup with a certain amount of potatoes and a certain amount of carrots. Now, how many potatoes and how many carrots could she have in each bowl? Well, if we know that the common factor is 10, 10 times what would give me 50? 10 times 5. And 10 times what would give me 40? Well, 10 times 4. So we know that if we had 40 baby potatoes, there would be 4 potatoes in each bowl. If we have 50 carrot sticks, then we would have 5 carrot sticks in each bowl. The last problem is talking about plants. So it says, I want to plant 45 sunflower plants, 81 corn plants, and 63 tomato plants in my garden. If I put the same number of plants in each row, and each row has only one type of plant, what is the greatest number of plants I can put in each row, or in one row? So go ahead and answer, would this be greatest common factor or least common multiple? If you said greatest common factor, you are correct again, because what we're trying to do is we're trying to take the sunflower, the corn, and the tomato plants and figure out how many in each row we can have. So it's almost like we're grouping the plants together. So let's go ahead and use our prime factorization. So the prime factorization of 45 would be 9 times 5. 9 breaks down into 3 times 3. So the prime factorization of 45 would be 5 times 3 times 3. For 81, I'm going to go ahead and break that down into 9 times 9, and that breaks down into 3 times 3 and 3 times 3. So my prime factorization of 81 is 3 times 3 times 3 times 3. And last but not least, I need to break down 63. Well, I know 9 times 7 is 63. 7 is prime. And 9 breaks down into 3 times 3. So for 63, my prime factorization would be 7 times 3 times 3. Now, I have to know what's in common between all three plants. So even though 45 and 63 both have a 5 and a 7, that's not in common with 81. So the only thing that they have in common is this group of 3's and this group of 3's. So if I take those two prime factors that all three numbers have in common, your answer is 9. So what is the greatest number of plants I can put in one row? The answer would be 9 plants.